Looking at example 2, I'm going to streamline this whole finding the greatest common factor thing for you. I want you to see certain things you can do. The greatest common factor is a mixture of the biggest number that divides the numbers along with the smallest power of each common letter. Alright, so if you consider that and consider our terms here, we have term 1 is a cubed x squared m squared, term 2 is a squared xm cubed, x is to the first power, and term 3 is a to the fourth x cubed m squared. Everything's out of power there. First thing you notice about this problem is all the numbers are missing, right? There's no coefficients.
There's a 1 in front of it.
Well, there's a 1 in front of it, absolutely true. But there's no numbers visible in this problem. When we're trying to factor and there's no numbers, putting 1s in front wouldn't be a helpful step. It would cause you to write down more stuff than you have to, so I wouldn't worry about it. If numbers do show up, then you have to factor in the numbers. You have to consider the numbers in the greatest common factor decision. What I want you to see here, to make the greatest common factor, every single time, these are already factored right there in front of us, so to write them out again would be overkill, right? Unnecessary. So, greatest common factor is what's common, and I can see very clearly that all three terms contain a, x, and m. A in all three, x in all three, m in all three. And what I'm supposed to do is take out the lowest power of each one. So looking at a, the choices are 3, 2, 4, I take 2. For x, my choices are 2, 1, 3, I take 1. And for m, I have 2, 3, 2, I take out 2. Alright? So just like that, I found the common factor without going through the whole process that I did in the last one. I'm doing most of the process mentally. And again, as you get better at finding greatest common factor, hopefully you'll get to that point too, where you're doing that mentally. At this point, I'm going to put a parentheses. Anytime you're factoring, and again, when the directions say factor the greatest common factor, you write the greatest common factor, and then in parentheses you write the leftovers. And leftovers is just divide each object by the common factor, and whatever's left over is what you get. With letters, you're dividing, but that requires you to subtract powers. So A, 3 minus 2 is 1. X, 2 minus 1 is 1. M, the powers are the same, so they cancel. So if the powers are the same, they cancel. If everything cancels, you have to write the number 1 down.
Okay.
Okay, if that happens, which hopefully it'll happen today, it's not happening on this one, but if everything cancels, there's always a 1 there. All right. Next, I want you to notice there is a plus sign here. So I'm going to put a plus sign here. All right, always get the correct signs. There's no reason to get these wrong. Do everything right, thinking of a sign wrong, get the wrong answer. So whatever the sign is, carry it down. A squared over a squared cancels. X over x cancels. M cubed over m squared leaves m. 3 minus 2 is 1. Then we have a minus sign, so I write a minus sign. A to the fourth over a squared, we subtract 4 minus 2 is 2. X to the third divided by x, 3 minus 1 is 2. M squared over m squared cancels. Alright? What's left in the parentheses, this and this can't add or subtract because the powers don't match. That's not the right letter, so adding and subtracting is not possible. If it wasn't possible up here, it won't be possible down here. But if it is possible, you should do it. And I would do it up here before I factored, but usually they won't add or subtract. And again, once you get everything left over in the parentheses, that's when you're done. When the directions say factor, that is your job to get all the way to that point on the problem.